So welcome learners in Introduction to Electric Vehicle and Hybrid Electric Vehicle, week number 6, and today we will discuss about flywheel and fuel cell technologies. So today we will see the flywheel and the fuel cell technologies for EV. So in the previous lecture we have seen the fundamental of ultracapacitors, and we have also seen how it works, and we have discussed about what are the different types of ultracapacitor available, and we have seen the application of ultracapacitor in EV. So in this particular lecture we will see the fundamentals associated with flywheel and fuel cell, and we will see how the flywheel and fuel cell works, and we will cover the different types of flywheel and fuel cell technologies, and at the end we will see how this flywheel and fuel cell are applicable for EV application. So let us first understand the flywheel. As you can see in this particular picture, this is the typical picture of the flywheel. A flywheel system utilizes rotational motion to store the energy in the form of kinetic energy by rapidly rotating a mass. A flywheel rotor is set in a motion by electrical input. In the case of in this particular figure, the motor or generator set are used to rotate the flywheel rotor, and it remains in the motion until it is required to release the stored energy. So whenever we require stored energy of the flywheel, we have to stop this what we call the electrical supply of the motor generator set, and this flywheel energy can be released in order to utilize in an effective way. So flywheel rotor is the main component of flywheel energy storage systems to store energy, and its material can be a metal or a composite. So, and this flywheel is rotating in a vacuum chamber in order to get a required operation. So let us understand how this flywheel works. So there are two steps. The first step is the energy storage, when we are rotating the flywheel with the external forces with the help of motor, and the second stage is the energy release. So there are two steps involved in the operation of the flywheel. So let us understand the first one is the energy storage. The flywheel is a rotating disc or drum that stores kinetic energy when vehicle is accelerated. So whenever vehicle in a motion, so this flywheel stores the energy in its what we call the flywheel rotor, and when the vehicle brakes or slow down, then this flywheel absorbs and stores some energy that would be lost otherwise as a heat. So this is the typical application when energy storage come into picture. The second step is the energy release. So when needed, such as during acceleration, the flywheel release the energy, stored energy, to assist the propulsion and provide additional power to the vehicle so that it can drive properly. So this is the typical application of the flywheel in the case of electric vehicle. So let us discuss about different types of flywheel. On the basis of construction, we are having two types of flywheel. The first one is known as solid disc flywheel, and second one is known as rimmed flywheel. And similarly, on the basis of velocity of the flywheel, we are having two types of flywheel. The first one is known as high velocity flywheel, and second one is known as low velocity flywheel. So flywheel is used in the EV application to store the energy whenever acceleration comes into picture. So next, our next topic is fuel cell. So fuel cell is one of the renewable energy sources that can provide the energy, and that energy can be used to run any devices. Okay, so here you can see the typical picture of a fuel cell, which is having the cathode and anode separated by a membrane. Cathode is what we call, in the cathode we are having the what we call the oxygen in, whereas in the anode we are having the hydrogen in. So hydrogen is the main fuel of a fuel cell, and apart from hydrogen we are having other fuel as well. Okay, so fuel cell is a basically electrochemical device that uses the reverse electrochemical reaction and continuously converts chemical energy content of a fuel into electrical energy. Electrical energy, water, and some heat, as long as fuel and oxidant are supplied. So fuel and oxidants are considered as a input to the fuel cell. So it supplies the power till it is getting the fuel and oxidant. Okay. So a single cell consists of a electrolytic layer in contact with porous anode and cathode in either side. A fuel typically considered as a hydrogen fed into anode side, which is a negative electrode, and an oxidant, generally it is a oxygen, is fed into a cathode, which is a positive electrode. What happened then? So in this particular fuel cell, hydrogen is fed into anode side, whereas oxidant, that is oxygen, is fed into a cathode side. So let us see why this fuel cell are more prominent in the case of power generation. The first important point in this is low emissions. So there is no byproduct in the case of what we call the fuel cell. Only water and small amount of heat is generated, and that can be easily discharged into atmosphere. So there is no harm in the atmosphere when it comes into the emission side. Quiet operation. The overall operation of the fuel cell is very silent compared to the IC engine, and it doesn't have any kind of noise pollution. High efficiency. The fuel cell converts the chemical energy into electrical energy directly. So there is no intermediate conversion stage involved in the fuel cell operation. So the efficiency is very high in the case of fuel cell when it is compared with the IC engine. Scalability. You can scale from small portable device to a large power plant depending upon your application. So it is having a wide, so fuel cell operation can cover wide range of application. You can consider from a handheld electronics to the what we call the big size power plant. You can consider it. The next one is the energy security. They can be deployed in a distributed energy system, enhancing the energy security and reducing the dependency on centralized power grid. So definitely it will reduce the cost of the transmission and distribution. Next point is the long operational life. So with proper maintenance, the fuel cell can be long operational lifespan, making it durable energy solution compared to the other form of energy, especially if you compared with the internal combustion engine driven power plants. The next point is the fuel cell based plants are very compact in nature. So definitely it will require less space for the power production. Also, this fuel cell can be integrated with the renewable energy systems so that it can enhance the what we call your renewable energy production. Also, the fuel cell can utilize hydrogen that can be produced from any renewable energy sources such as solar plant or we can say wind power plant, adding them into a cleaner energy transition. So fuel cell can be considered as a clean energy if we put those renewable energy for hydrogen production. The next one is the fuel flexibility. Like in the fuel cell, there is a flexibility of fuel that is utilized. So we can have a hydrogen, we can have a natural gas, methanol, or other fuels can be used. So it offers the versatility in the fuel that is used. Next one is the reliability and durability. Fuel cell have fewer moving parts compared to the traditional engine, leading to a potential lower maintenance and higher reliability. So it is having the better what we call the so it provides better reliability and durability compared to the other one. So this particular slide indicates the different applications. So from this slide you can understand the fuel cell can be used for the portable electronic devices to a submarine. So there are other applications as well. This can be used for the decentralized power generation. It can be used for the automotive application. It can be used for the space application. Nowadays, company is using this hydrogen for the aircraft making. So in future, no doubt, the hydrogen can be used in the space application as well. It can be also used as an emergency power supply, like your UPS. Like it can easily replace the battery in the UPS. Also, it can be used for the military application in a distributed manner, and it can be used in the submarine and truck and buses. Recently, Government of India has taken an initiative for the green energy mobility with the help of these hydrogen based buses and trucks. So based on the various factor, we are having the different types of fuel cell. So based on the fuel and oxidant, we are having the this type of fuel cell. The first type is the when pure hydrogen and pure oxygen is used as a fuel and oxidant. The second choice is the hydrogen rich gas, and second one is the hydrogen oxygen, hydrogen peroxide can be used. Next one is ammonia and air. Sometimes like hydrogen is not readily available, so ammonia is converted into hydrogen, and hydrogen is used as a fuel in the fuel cell. So sometimes hydrogen is not readily available, at that time ammonia can be used. The next type is the synthetic gas and air, and next one is the hydrocarbon and air, hydrocarbon in a liquid form and air. So this classification is based on the fuel and oxidant. The next classification is based on the electrolytic. The phosphoric acid fuel cell, the next one is alkaline fuel cell, and next one is the polymer electrolytic based fuel cell, molten carbonate fuel cell, solid oxide fuel cells. So those are based on the electrolytic. Next one is the based on the operating temperature. So whenever we are operating the fuel cell below 150 degrees Celsius, then those kind of fuel cell are considered as a low temperature fuel cell. And whenever we are operating the fuel cell in between 150 degrees Celsius to 250 degrees Celsius, then it can be considered as a medium temperature fuel cell. And next one is the high temperature fuel cell, which operates in between 250 degrees Celsius to 800 degrees Celsius. And whenever we are operating the fuel cell at 800 degrees Celsius to 1100 degrees Celsius, then it's come in the category of very high temperature fuel cell. Next is the based on application. So based on the various application, we are having the space application based fuel cell, vehicle application based fuel cell, defense application based fuel cell, commercial application based fuel cell, and submarine fuel cell. And based on the chemical nature of electrolyte, we are having the three types of fuel cell: the acidic electrolyte fuel cell, alkaline electrolyte fuel cell, and neutral electrolyte fuel cell. So we can categorize on the basis of those factors. So let us understand the fuel cell reaction. So at the anode end, we are getting two electrons from the hydrogen, and this electron is traveling through a load to cathode, and we are getting the electrical output from them. So this is how, so this particular reaction indicates how the electricity is generated from the fuel cell. No doubt the what we call the voltage of the fuel cell is very low. So that is why what we are doing, we are increasing the voltage by putting a DC-DC converter in between the load and the fuel cell in order to get the boosted voltage, and we can meet the requirement of the load. So here you can see those kind of reaction. So in this particular figure, we can this particular illustration indicates how these fuel cell are working. As you can see, we are having the red bubbles and blue bubbles. The red bubble indicates the hydrogen fuel, and the blue bubbles indicates the oxidant. and it is, as we know, as we have discussed, these two gases are injected in the anode side and cathode side respectively, and whenever we are injecting these two gases, we are getting the electrical output across the two electrodes. Okay, and you can see there is a what we call the exchange membrane in between the what we call the electrodes, and we are having the catalyst in between those two electrodes. So there are 5 steps are involved in the fuel cell operation. The first one is the fuel supply. Hydrogen is supplied to the anode while oxygen is supplied to the cathode. The second one is the electrochemical reaction at anode. Hydrogen molecules are split into a proton and electron at the anode through a catalytic reaction. The next step is the electron flow. Electrons travel through the external circuit generating an electric current. The next one is the proton movement. Proton moves through a electrolytic to cathode. The next one is the reaction at cathode. At cathode, proton, electron and oxygen combines to form a water and heat, which are expelled from the fuel cell. This process continuously generates electricity as long as fuel and oxygen are supplied to the fuel cell. So this is the working of fuel cell. Let us see how this fuel cell can be used for the for a vehicle. So let us understand how this fuel cell can be used for a vehicle. As you can see, I have taken this particular figure from the BMW. Okay, so here you can see there are 3 different color coding. The first one is the blue, second one is the green, and third one is the red. The green indicates the hydrogen section. Okay, so we are having the hydrogen tank where hydrogen is basically filled as a fuel, and then we have a fuel cell section. Okay, so fuel cell section is getting fuel from the oxygen tank and external environment because it requires oxygen as well as an oxidant, and it is getting external power from the battery, because for the fuel cell operation we required external power as well. So we are having the auxiliary battery as well, and output of this fuel cell is connected to a electric train system. It is basically a motor. Okay, then we have a propulsion system. This red one indicates the propulsion system. It is a mechanical part of the vehicle. So as you can see, we are having the least component in the fuel cell based vehicle. So there is no such harmful byproduct of this fuel cell based vehicles. Okay, so however its range is very less. So in future, in order to increase the range of this particular vehicle, we can add the what we call the battery as well, so that it can have a hybrid system, and we can significantly increase the range of the vehicle. So battery and hydrogen both can have a better choice for the electric vehicle. They are having a good investment in this particular Alstom company, which is running the train via fuel cell. So it is a great initiative for this particular country, and this kind of initiative must be taken from other country as well, so that we can have a greener transportation, and it is a great steps towards the greener transportation. So in this particular lecture, we have seen the fundamentals and function of flywheel and fuel cell, and we have also discussed different types of available fuel cell and flywheel, and subsequently we have seen the application of flywheel and fuel cell, and we have seen the concept of fuel cell based vehicle. So these are the differences that I have taken for this particular lecture. Thank you.